Hello, this is the second half of Chapter 11 about covariance and correlation coefficient. In the previous lecture, we defined the covariance and the correlation coefficient. Basically, we would like to understand the relationship between two variables. In particular, we are assuming that the trend is linear. The relationship between the two variables is linear. And then we are interested in two things. First, the direction, where is the how the trend line looks like, and the strength of the relationship, how much the observations deviate from the trend line. These two components are what we are looking for in the relationship between two variables. And as the basic idea is, the covariance is defined as the average, some kind of average of the product of two deviations. The product of deviations of x and y, two variables. And the correlation coefficient is the standardized covariance, which is defined as covariance divided by both standard deviations. Then the major difference is that the covariance captures the direction, whether the trend is going down or going up, but it does not capture the strength of the relationship. However, the correlation coefficient captures the slope, but does not capture the slope, and as well as it captures the strength of the relationship. So you, like, when you read the measures, you have to be careful what you are looking for and what you can interpret, how you can interpret them. And today we are going to continue the same topic, but the difference is, as we did in chapters 3 and 4, in that chapters, when you define the mean or the median, the variance, or like them, we considered two cases. One is, the first case is when the data are given as a raw data. So just we have a list of numbers, list of observations and their outcomes. Then we learned how to calculate the mean or the variance or the median. And the other case is when you are given the probability distribution table. The probability distribution table is not a raw data. It's processed information. And when you have the probability, the main difference is that the probability should be used as a weights. So you have to consider weighted outcome to compute the average. That was the main difference, and we are going to now, in the previous lecture, I simply considered raw data. We considered 3 country case, like Mexico, US, and Canada, or on Excel we considered 183 countries case, which is also raw data because there are 183 columns. But now, as you see on the slide, it is a probability distribution table. It's not 3 outcomes. There can be many possible outcomes, but we summarize them into a probability distribution. So the story goes like this. Suppose that you have 2 stocks, or financial assets. Say there are 2 financial assets, and their returns depend on the economic state. And say I'm going to characterize A and B as A is procyclical, which means when the general economy goes up, the return from A also goes up, but when the general economy goes down, A goes down too. So it moves together with the market. So it's A is procyclical and it's risky. It's up and down differ a lot. On the other hand, B is clearly different. First, B is countercyclical, which means while the market is going up, when market is going up, B goes down. and if market goes down, then B goes up. In reality, such an asset would not exist. I think it does not exist. Such an asset, it does not exist, or if it existed, it will be super expensive because it's rare. And I'll assume that B is less risky, so the up and down is not that different. And to simplify the model, I am going to consider three market state. So the general market can be in boom state or normal or recession. And I assign probabilities 25%, 50%, and 25% for the three states. And once the market state is determined, the return from each financial asset is determined according to the market. So I assume that the return from A is say 20. Say you can think it as 20% return, rate of return a year. And in normal market, A returns 8%, and recession 4%. Simply, I will call them 20, 8, and 4. And B, financial asset B returns 6% when the market is in boom. But when the market is recession, it's doing better. So 14% in recession and 10% in normal period. So, of course, everything is fake numbers, imaginary asset. So what we are going to do here is we are going to study the relationship between these two financial assets and its implication on your portfolio when you combine them, or how you allocate your investment, and in that decision, in particular, when you calculate the risk, the covariance or the correlation coefficient plays a very important role to assess the risk. So let's see. First, we have to learn how to calculate the covariance. In this case, the idea is the same. We have probabilities, and the covariance is some kind of average, is the average of the cross products of deviations. But when you calculate the average or the weighted sum, you have to use the probability as the weight, right? So let's look at this. So there are probability and outcomes, outcome from A, outcome from B. First step is to calculate the mean, and I made up the numbers so that the mean equals to 10 for both assets. So the mean of A is 10, also 10 for B. And then deviation for A is 20 minus 10, and 8 minus 10, and 4 minus 10. Subtract 10. Also, the deviation for B is 6 minus 10, 10 minus 10, 14 minus 10. Right? You subtract the mean, and then you will multiply them. And if you did not have the probability, after the multiplication, we summed the result, the products, and divide them by n minus 1. But now we have the probability. We have to utilize the probability, and after multiplying the deviations, we have to put the weight of probability to them. So we multiply 10 times minus 4, and it's weighted by the probability 0.25. So it becomes minus 10. And the second outcome, minus 2 times 0, is multiplied by probability 0.5. It receives a weight of 0.5. Anyhow, in the end, it will be 0. And finally, the third outcome, minus 6 times plus 4, is weighted by 0.25. So it results in minus 6. So now now you have to sum the weighted cross product. Remember, this is exactly what you have done in the mean, when we calculate the mean, and when you calculate the variance. We use the same idea at that time. So to compare what we did there, maybe it would be helpful to review the slide of chapter 4 or watch the videos from chapter 4. So anyhow, you get -10, 0, -6, which are weighted products of deviations. Their sum is the covariance. And the covariance is simply 16, -16 between A and B. So we get a covariance of -16. By the way, so remember, covariance, the absolute value of the covariance doesn't mean anything here. We cannot interpret the magnitude and we cannot compare that, but we can tell that they are negatively correlated. The covariance is negative, so when A increases, B would go the other way. And it's clear from the numbers. So as A goes down, B goes up. So they are moving the opposite direction. So their covariance should be negative, right? That's clear. And okay, that's simple. I believe it's not new, totally new to you how we calculate how we utilize probability in calculating covariance. But now we are going to apply that result to actual portfolio allocation problem. So I'm going to start from very simple example first, and then I'm going to make it more general. I'm going to stop the video here, and I will start in a new video. Thank you for watching. See you in the next one.